All right, here's going to be our first look at some basic combination circuits. And today, let's just focus on finding the resistance total. Let's not worry too much about all this. Let's just find out what the resistance total would be if we broke it down into a very, very basic circuit. So I've got a little diagram here that's going to show the steps that we're going to work it down to. And as you can see, the simplest thing is going to be to eliminate this right here. So this question mark right here is the value of this resistor right here. Well, that resistor is going to be representation of this parallel combination of two resistors here. So we're going to take these two resistors in parallel and use the parallel formula to create one resistance value and then insert that into just this basic series circuit here. So that's going to allow us to break it down step by step. So as we know for parallel circuits, to find the resistance total, which is what we want, the resistance total, but only of this section here, we're going to go ahead and put in our formula, and it's going to be 1 divided by 1 over 12 plus 1 over 6. So if we put that into our calculator, remember your parentheses there, you should get 4 ohms. So the resistance total just for that one part is 4 ohms. We're not going to be plugging anything down here yet because this isn't a real resistor. This is just a placeholder value. So from here, now we're at this point and we have a value for this missing resistor in the series portion. All we need to do, since we're in series now, is add these values together. So we went from our combination circuit and broke it into a series circuit. And now for our resistance total of the series circuit, to get this value, we're going to take R1 plus R2 plus R3 plus R4. Now R3 here is not a real resistor again. This is just a placeholder. So when you're solving these, be careful you don't just start plugging those in down there. In this little demonstration here, we're just looking for the resistance total. And we're going to stop there. So if we're adding those together, all we're doing is adding 3 ohms plus 6 ohms plus 4 ohms plus 5 ohms. So the total resistance for the circuit is 3 plus 6 plus 4 plus 5, which gives us 18 ohms. So again, we'll go ahead and stop right there for this one. Tomorrow we'll come back and we'll work our way from top to bottom on this. But for the purposes of just breaking this down into its most basic form, which is just the thing we were doing pretty much day one, this is the process to break down that more complicated one to at least find this category here. So we're going to find our voltage, current, and resistance totals, and later we'll even be finding the power totals. So this value right here is going to go right there, and we'll go ahead and stop right there. Alright, so breaking down a combination circuit into a simple circuit and finding the resistance total.